All right, welcome to the Explainer. Today, we're going to pull back the curtain on something you use literally every single day, probably without even thinking about it. So let's just dive right in. So, you ever stop and wonder, what is that secret sauce? You know, that invisible brain that just seems to know exactly what you want right when you want it?
Okay, think about it. Last time you used Google Maps, right? It didn't just give you a map, it told you about the traffic jam up ahead, found you a faster route, and nailed your arrival time down to the minute. It's kind of spooky, right? How in the world does it know that?
Or what about Amazon? You're just browsing, and boom, there's that one thing you were just talking about. And Netflix? Come on, it tees up a show that you totally binge watch all weekend. It really feels like they're reading your mind, doesn't it?
And hey, let's not forget the real unsung hero of our digital lives, the spam filter. I mean, think of all the junk it silently catches every single day. Keeping our inboxes clean, we don't even have to lift a finger.
Well, the answer to all of these things, that invisible brain power, it's machine learning. It's the engine that's running behind the scenes of just so much of the tech we rely on. Now, this idea isn't exactly new. The term was actually coined way back in 1959 by a pioneer in AI named Arthur Samuel. And his definition is just, it's so simple and perfect. It's the field that gives computers the ability to learn without being explicitly programmed. So instead of a developer writing code for every single little thing, you kind of just let the machine figure it out on its own. Okay, so how do we nail that down a bit more formally? Well, the modern definition breaks it down into three parts: task, performance, and experience. You can think of it like this. A program learns from experience, which we'll call E, to do some task, T. And we measure how well it's doing with some performance metric, P. And here's the key. Its performance at the task gets better and better the more experience it gets. That's it, T, P, and E.
So let's make that concrete because it can sound a little abstract. Look at handwriting recognition. The task, T, is just classifying what a word is. The experience, E, is feeding it a huge data set of handwritten words that are already labeled. And the performance, P, well, that's just the percentage of words it gets right. Simple. Or take a self-driving car. The task is driving on a highway. The experience is watching a whole bunch of video of a human driving. And the performance is, you guessed it, how far it can go before it messes up.
All right, so now we get what learning is for a machine. But the big question is, how does it actually happen? How does a computer get all that experience in the first place?
Well, it basically boils down to two main flavors. First up, you've got supervised learning. The best way to think about this is like studying for a test with an answer key. The computer gets a bunch of labeled data, meaning it's shown an example and told this is the right answer. It has a teacher. Then you've got unsupervised learning. This is the total opposite. You just give the machine a mountain of data with no labels, no answers, and you just tell it, go find something interesting. It has to find all the hidden patterns completely on its own.
Let's break down supervised learning with a super simple example. Say you want to teach a computer to recognize shapes. Step 1, you feed it a ton of labeled pictures. You show it a square and say, this is a square. You show it a triangle and say, this is a triangle. Step 2, the program starts to learn the features. Things like squares have 4 sides, triangles have 3. And finally, step 3, you show it a new shape it's never seen before. And based on what it's learned, it can go, aha, that's a triangle. Pretty cool, right?
But wait, there's more. It's not just about having an answer key or finding patterns in the dark. There's a third and really powerful way machines learn, and it's called reinforcement learning.
The analogy here is just perfect. It's like teaching a dog a new trick. You don't sit the dog down and explain the physics of fetch. No way. You reward it when it does something right, maybe with a treat. With reinforcement learning, it's the same idea. You don't give the computer the right answer. You just give it a reward when it gets closer to the goal. It learns totally through trial and error, figuring out what actions get it the most points. This is exactly how AI gets so good at video games or how a robot learns to walk.
Okay, so just to recap, we've got supervised, unsupervised, and reinforcement learning. 3 different ways machines learn. Now, let's tie this all back to those apps we were talking about at the beginning. And this is where it all clicks into place. You know when Facebook or Google Photos automatically suggest tags for your friends? That's supervised learning. When you talk to Siri or Alexa, that's speech recognition, which is a type of ML. That spam filter we love? Yep. Online fraud detection that keeps you safe? You got it. It's even helping doctors find tumors and diseases earlier. It's all powered by these learning algorithms, quietly working in the background.
So as you can see, this is not science fiction. This is happening right now, and it's giving machines some serious superpowers. We're talking about the power of scale, being able to analyze more data in a second than a human could in a lifetime.
and the power of prediction, forecasting everything from traffic jams to disease outbreaks. It's already changing everything.
And you know what? We're really just scratching the surface here. The whole point of machine learning is that it's designed to get better with more experience. That means these systems are constantly improving, constantly advancing. And as we feed them more and more data, they're only going to become a bigger and bigger part of our world, which naturally raises some pretty big questions we all need to think about. So if there's one thing to take away, it's this. Machine learning is all about computers getting better through experience. And as these machines get better and better at learning from our data, from the world we create, it leaves us with one really important final question. What should we be teaching them?